A separately excited DC generator. Separately excited DC generator. Dynamo. DC dynamo generator. Rotating at the speed of 1500 RPM. That is the speed RPM. While it is rotating at such a speed, excitation current is 3 amps. Okay. At the same time, field current is 3 amps. It is separately excited machine. Okay. Let me draw the relation. Here's an armature, dynamo, separate excitation is applied. Here are the armature terminals. Here is the separate excitation terminals, and you have applied some external separate power for the field circuit, and field current is 3 amps when there is a speed of the shaft which is 1500 RPM. There is such a connection diagram behind these questions, and then when there is such a speed and field current, EMF induced in the armature is 160 volts without any saturation. Okay. Armature EMF at the same time. Here are 3 data, 3 amps, 1500, and armature EMF is 160 volts at the same time. Those are given conditions of separately excited dynamo in the question. And the question 1A. If field current is 2.5 amps and rotation is the same, please calculate the new EMF. Calculate the new EMF. Machine must be linear and there must be no saturation. Okay, you should assume that machine is acting linear and without saturation. Without saturation. Otherwise, you cannot solve this problem, because Houston, remember no load curve again. Remember no load curve. Here it was. Field current versus EMF under a certain speed. Houston, it is the same. Let's check it out. In the beginning, it was 1500. And then in the second case, again, it is 1500. So, here is the, I don't know what the relation is, but let's say here's such a linear, non-saturated EMF relation. Houston, I don't know what it looked like, but I just think about it. And it was 3 amps excitation, and then the induced voltage was 160 volts. PV in the armature, not across the terminals. There's no load mentioned. There's no load mentioned yet. It is just armature EMF. It is given here. There would be some voltage given, but there's no mention about load. There's no given terminal voltage. Okay. And Houston, there's a change in the question. Field current is decreased down to 2.5 amps. Let's check it out. Here it is, at the same speed. And what is the EMF? Houston, it looks easy, yes. What is the armature EMF new value for the 2.5 amps excitation. Ta-ta. It looks like proportional. Yes, it looks like proportional. Sometime, perhaps, there is a given no-load curve. For example, in a question, I can supply a curve. In such a case, here you see, for 3 amps, you should cut the curve, no-load curve. You should find out here the old EMF, and then you should substitute 2.5 cross the no-load curve, and then you should find the new value of EMF. In case it is given as a function of curve or nonlinear relation, as you see from the figure. Here in the question, it is said that there's no saturation, nothing about linearity, so you should assume that it acts as linear. In all questions, I assure you, I assume machines linear. If there is nothing especially emphasized the linearity, sometimes I give such a curve, so now there is no need to say linear or non-linear. Everything is given in terms of curve here. Okay, now let's answer the question. It is very easy. Let me make it in my pen more thicker. EMF is equal to Ka times flux times speed. I don't know what the Ka is, but is after manufacturing it is constant. But I know field is similar to a no-load curve, so it is given linear. Let me say zeta times If is equal to flux W and K. That is the, let's say, armature old value, and new value is the Ka. Again, zeta, slope of the curve is zeta times If new, let's say old, and W, which is same, and make a division or proportion. Ka's will be eliminated, zetas will be eliminated, and speeds will be eliminated. So what is the new EMF? New EMF will be equal to old EMF times new current, If new, over If old. Houston, it was 160 volts when there is a 3 amps excitation, but the new field current is 2.5 amps. So that is the result. 160 times 2.5 over 3 makes 133. Here it is, 133.3 blah 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 volts. Houston, that is the new value of induced EMF. The answer is given here. The A answer is here, and you see 133 volts. Okay, let's check it out. Question B. When there is a 2 amps excitation current, machine speed increased up to 1600 RPM. What is the new value of the EMF induced in the armature? Okay, the excitation current is 2 amps, very new. Let's say If brand new, let's say brand new yepyeni brand new value is 2 amps. And then speed brand new is 1600 RPM. Here's, ladies and gentlemen, I have confused something. The guy has given speed in terms of RPM, but here's, I have written angular speed in terms of radians per second. I know since they are identical, they will be eliminated. So I haven't given any detail about this, but you know, angular speed of the shaft is equal to 2 pi n/60. That is RPM. That is radians per second. Radians per second. In case you need, you can use that relation. Okay, here perhaps we need to use. Okay, we have two values. One is 160 volts under 3 amps and 1500 RPM speed. Again, we have a new value, which is 103. We have just calculated here, 133.3 blah blah volts under 2.5. Was it? Yes. 2.5 amps excitation, and again 1500 RPM. Houston, right now it is asked whether, what is the brand new value of last value of EMF under 2 amps and 1600 RPM. There are two changes. Take care. You can use any of these given relations. Let me write the last one first. Armature EMF brand new value is equal to Ka times flux times, instead of flux, I have given a linear relation, zeta times IF brand new. I have already talked about this. That was a linear relation coming from no load curve. And here is the angular speed, which is brand new, the latest value, which is coming from 1600 RPM. And here you see, let me substitute the original value, 2 pi n brand new over 60. And continue the old one. Let's say the first one, this one. Armature EMF is Ka times zeta times IF old, or first, let's say nothing. It was, or I said old. Okay, old. And the old speed, n old over 60. Now, let me divide all those equations, and Ka will be eliminated, zetas will be eliminated, 2 pi over 60 and eliminated. What is the result? Armature EMF brand new value is equal to, in terms of old value, times field current IF brand new over IF old times N brand new over N old. Here you see the relation. Let me calculate. Armature old value, it was 160. Brand new value 2 amps. Old value was 3, initial one, I mean the oldest one, 3 amps. It was 1500 RPM. It was right now, final value, it was 1600 RPM. That's it. Let's make the calculation. 100, let me copy this one. 160 over times 2 over 3 times 1600 over 1500 makes 113.778 volts. Houston, that is the brand new value, final value under such a new excitation current and such a new speed. Here you see the same result. Very easy. Quiz type questions. You can also reach Turkish version of these problem solution in my YouTube playlist.